Hi there, San Francisco HTML5 user group. I'm Bruce Lawson. I work for Opera, the lovely cuddly Norwegian people who make the Opera web browser for desktop and phones and TVs and devices. Obviously, as you've noticed, I'm not in San Francisco. I wasn't allowed in by immigration for not being nearly beautiful enough to wear a red bikini and rollerblade around your Californian beaches. But hopefully this streamed presentation will do the trick just as well. Anyway, the subject for the next hour or so is HTML5 Multimedia, where we are and where we're going. So way back in antediluvian times, in internet years, back in 2007, a colleague of mine at Opera, Onno van Kesteren, wrote to the WhatWG working group, the guys who are making what we now call HTML5, and suggested a native video element with a simple API. This API has got more complicated now, but it needed to. It's no more complicated than it needs to be. It has special video semantics, and basically it's grown from there. It's now in all the browsers, including IE9, as is audio, the sister tag, if you like, that shares the same API. So pre-HTML5 video, here is what we were dealing with. This is basically the code that is vomited out by YouTube when you hit the embed button. And I call this cargo cult code. And the reason it's cargo cult is people copy and paste it. They copy it out of YouTube and paste it into their pages. You never wonder how it works. You never look at it too closely. You don't know why it works. And this is, to use a computer science term, this code is fugly. Okay, it violates the dry rule. Do not repeat yourself, DRY, because we've got a width and height here, and we've got a width and height here. It also has the URL twice here, for example. This embed element here doesn't validate in any version of HTML prior to HTML5. It validates now because it's used all over the place. It's really handy for putting plugins on pages. So it's just made a legal part of the language. But fundamentally, this code here is nasty. And none of us, I think, like nasty code. So in the HTML5 world, we get this. Now, there's a video element, as you can see. There's a closing tag as well. We'll come to the reason why in a little bit. This is the source of the video. Here it's a WebM file. We'll come to the file types later. Excuse me. And nearly everything else, apart from the source, is optional. Controls tells the browser that we want it to give us a play, pause, toggle, a video seeking bar, probably a volume control. These are different from browser to browser, but all those functions are represented. Autoplay is an attribute that you use, oddly enough, when you want to autoplay a video. You shouldn't do this. It's wrong and it's evil to autoplay videos. If your web user is an assistive technology user, so for example they are listening to the text on your page synthesized by a screen reader so they can hear the text, and your video of your kittens on a skateboard automatically starts with its rock and roll theme tune, your users will be mighty annoyed at you because it'll be drowning out their screen reader output. However, it's there, oddly enough, or paradoxically enough, as an accessibility aid. The idea is that if you couldn't declaratively say autoplay, people would, as they do now, do it with scripts. Because it's easier to type autoplay than script it up, people are likely to do that. And then it's trivial for browsers to have some kind of preference setting that says never autoplay videos. It's much harder for browsers to apply heuristics and look through all the scripts on a page to find out where the videos are autoplayed and thus turn it off. So what appears like an accessibility no-no by allowing you to say autoplay actually has the potential to be an accessibility aid, which is jolly nice. Next we have poster. Now the poster attribute allows you to specify an image that is shown in place of the video until the video started. If you don't give a poster attribute, the browser will give you the first frame of the video, but that may very well be just a black screen or a white square and not look terribly enticing and encourage your visitors to click and start the video. So if you want, you can put poster. If you don't, it defaults to the first frame. Next are the width and the height in pixels. If you don't put these in, then the browser will default to the intrinsic width and height of the video. And if you accidentally or deliberately change it so that the aspect ratio would be changed, the browser won't stretch the video, but instead will letterbox it. And basically the stuff in the middle here, in between the tags, is fallback content for older browsers. So this stuff here is only shown to browsers that can't actually do native HTML5 video. What I've got here is the markup that gives a link to the video, and then the user can download it and save it to their hard drive and then click on that and view it in an operating system media player, which isn't the same experience as seeing the video in the browser, but at least the user gets the content, and after all, content's the thing. Your website exists to deliver the content, so delivering the content is the job. So audio is exactly the same. You can't put a poster because there's no physical manifestation of audio unless you say controls. If you don't say controls, your audio will play, but there's nothing at all to see on the screen. You can autoplay just as you can with video, and you can have fallback content in the middle for older browsers, just like with video. There's a few other groovy things you can say. So for example, on video and audio, we can say loop, and that does what it says on the tin. It will loop around, and we'll see how we can use that in towards the end of this talk. There's also a preload attribute. Now, preload has three possible states. If you don't put any state at all, if you just say preload, then it defaults to preload equals auto. Preload none means that the browser doesn't actually grab any of the file until you click a play button to tell it to go. Preload equals metadata tells the browser to grab as much, or actually as little, of the file as it needs to be able to show you the first frame if it's a video, and to grab information about what kind of codec it is, the maximum length, etc. This stuff doesn't command the browser, it's a hint. You could say in your markup, do this, but if the browser, for example, knows that it's on a mobile phone, it might never preload anything, or if it detects that it's on a slow network, then it might change its preloading behavior. You can hint, but you can't actually tell it what to do. Okay, another really important fact to bear in mind about HTML5 multimedia is that this stuff is now native as part of the browser. So previously, if you put a video or some audio on the page with a plugin, what the browser would do was reserve some space on the page and then hand off the data that it's got to the plugin to be dealt with. And the plugins and the browsers being different programs from different organizations, different vendors, wouldn't necessarily talk to each other properly. So I don't know if you've ever tried, for example, having a drop-down menu in CSS that has to go over the top of a Flash movie, and quite often it will go behind the movie because the movie seems to have a higher Z index than your drop-down menu. That's an example of where it's difficult to control what's happening on that area of space that the plugin's going to use. Basically, when you hand off to the plugin, it takes over, but in HTML5 video and audio, it's all part of the browser. So we get advantages. So for example, keyboard accessibility is built in. It plays nice with the rest of the page, and there's a nice simple API for controls. So here's a demo. Let me fire up Opera. Oops. So this is the Opera incarnation of video. Now when I hover over it or tab into it, so I'm tabbing now obviously because I'm in a different continent, you can't see that, but I'm tabbing and I can trigger the video with the keyboard. It's actually quite difficult to make Flash movies keyboard accessible or tabbable to in browsers other than Internet Explorer. I can adjust the volume. There we are. Now these controls appear when I hover or when I tab into the video. There's no scripting, there's no images, there's nothing I need to do other than specify the controls attribute in my markup. And Firefox will look very similar, as will Chrome, as will Safari, as will Internet Explorer. By default, Opera, okay, that's enough Giga pudding. By default, Opera is keyboard accessible out of the box, as is IE9. Firefox is, as long as you have JavaScript on, and I don't think Chrome is yet, but I haven't looked lately. But potentially, it's all keyboard accessible out of the box. So here is another example. Now what I've done here is in my CSS, I've said my video is 100 pixels wide. Excuse me. Then I've said video colon hover. Video is going to be 400 pixels wide. So it's going to change dimensions when I hover over it. And in a bit of CSS3, I'm just giving a transition on that hover effect so it doesn't abruptly jump of, I think, half a second. So now, if I hover over my video, it changes size. Now, this may or may not be a terribly useful effect. You'll notice as well that the video still plays. There's no interruption in its playback. Maybe not the most useful effect, but my purpose here is to show you that because this is natively in the browser, you can control video just with CSS just like you can anything else. It's native, it's a first-class citizen of the web. Here's an example where in my markup I say controls, and then in JavaScript I'm removing the controls attribute from the markup. I'm writing out this button which is just a play pause toggle, and when I click on the button it sends a message to the video to play and pause like so. Now maybe that's not the most attractive play pause. Let's by the way, let's disable JavaScript, refresh, and now you can see that the browser default controls are there because the JavaScript hasn't removed the controls attribute from my markup. Let's re-enable JavaScript because I want to show you a demo. This isn't terribly attractive, of course, but that's merely because I'm rubbish word design. But here's an example made by the brilliant friend of mine, Patrick Lauker. what you've got here is an HTML form, and it's set to be 0.5 opacity, and when you hover over it or when you tab into it, it will be fully opaque, and there's a slight CSS transition, as you can see. I don't know if you can see this web font here, but this is just a CSS3 web font pulled in with the @font face rule. And this guy here, which is a volume control, hopefully you can hear that. If I fire up Dragonfly, which is our Opera's web inspector or Firebug-like device, you should hopefully see down here that that slider control is an HTML5 input type equals range, a new input control in HTML5 that manifests itself as a slider. So what you've got here is native video being decoded in the browser. We have standard HTML controls, buttons and form inputs that talk to the video using a simple JavaScript API, and this is all backwardsly compatible, because if you don't have JavaScript, it'll just use the browser's default controls. So this is an epic win. And if your marketing manager or branding consultant comes up to you and says, we've been bought out by Megacorp and everything needs to be in corporate lime green with yellow, you don't need to crack open your Flash authoring tool and change loads of assets. You just tweak some CSS, just like you do with any other web page that's based upon web standards, which is pretty much rock and roll. Right, so it should be as simple to make HTML5 video as it is to make this nourishing Japanese pudding that you've seen the advertising for. It should be a simple, easy to follow process. Unfortunately, it isn't, and the reason it isn't is video codecs. Codecs are formats in the same way that we have different image formats like JPEG, GIF and PNG. There are different formats for video. My boss, the CTO of Opera, and the guy who co-invented CSS, a gentleman called Halcombe William Lee, said in 2007 when Opera proposed the video tag, in addition to giving video an HTML element, we must also agree on a baseline video format that will be universally supported. It's important that the video format we choose can be supported by a wide range of devices and that it's royalty-free. Royalty-free is a well-established principle for W3C standards. So that was the theory. There are 3 formats for video on the web. The first one that we'll talk about, and possibly the least important these days, is called Ogtheora, and this is supported by Google Chrome, Mozilla Firefox, and Opera. It's free and open in inverted commas. There's no licensing and no royalties. Unfortunately, there aren't many tools for it. So if you want to start making OG in any kind of industrial process, you're pretty much going to be using the command line. Also, people who are cleverer than me about video formats tell me the container format itself isn't terribly well optimized for web. And that was explained to me as the browser has to download quite a lot of information just to get basic metadata out of it. But nevertheless, it's supported by all these 3 and it works pretty well. Okay, then there is H.264. H.264 is the name of the video codec. You often see this bagged up in a container with the file extension MP4. And this is ubiquitous. If you have a consumer video camera, it probably records to H.264. The trouble is that it's patent encumbered. There are licensing and royalties payable on it. If you are not charging money to view your videos, then you don't have to pay any royalties. If you charge money for people to see your videos, then you have to pay a royalty to use this codec to a group called the MPEG-LA. An advantage about H.264 is that it has excellent support in hardware decoding chips. So on a phone or something like that, rather than nuke the battery by decoding the video in software, it gets handed off to a chip that does hardware decoding. And this is really useful, particularly on things like your iPhone. This is supported at the moment by Google Chrome, but they've announced that they're dropping support for it, and it's supported by Apple's Safari and Microsoft's Internet Explorer 9. Then there's a new kid on the block, WebM. Now, WebM is the name of a container format. It is a video codec called VP8. And VP8 was developed by a company called On2 Technologies. And they also developed the codec that we met called Ogthiora. Now, Ogthiora was called VP3. So VP8 that powers WebM is 5 iterations better. And Google bought On2 Technologies for, I believe, 104 million US, and then they've open sourced that video codec. So it is open and royalty free, in inverted commas. The reason I put inverted commas around it is that I'm not a lawyer and therefore can't actually state that as a fact. It is web optimized. It's designed for the web, and it gives you pretty good quality for pretty good compression. Arguments rage about what's better, MP4 or WebM. However, WebM is good enough for what you're going to use it for, which is delivering video over the web. Hardware acceleration is on its way. If you look at the web page, webm-project.org, you can see that chip manufacturers have committed to supporting it. And WebM is supported by Google Chrome, Firefox, Opera, and interestingly, if the codec is installed on Windows, then IE9 will play WebM videos, but the decoder isn't actually bagged up as part of Internet Explorer yet. So, unfortunately, this means there is not one single format that we can deliver in. You can see this rather sad graph here. Interesting politics. The people who are most behind H.264, stroke MP4, are Microsoft and Apple, and by an amazing coincidence, Microsoft and Apple are also part of the organisation that licenses that codec and therefore gets money from people using it. But I emphasise this is merely an extraordinary coincidence. We have a similar situation with audio formats too. MP3 isn't supported by Opera and Firefox because MP3 has licensing or royalty issues in some territories. Ogvorbis is an excellent codec for audio. It's the one that Spotify use if you guys use Spotify, and that is supported by Opera, Chrome, and Firefox. Okay, so we know that there isn't one single codec that we can use for audio or video, which is a shame. Actually, the specification originally said every browser should be able to decode Ogthiora and Ogvorbis, but Nokia and Apple objected to that, and no consensus could be found for which codec should be used, so the mention of codecs was dropped, which isn't as cataclysmic as it appears. If you look at the HTML4 spec, it makes no mention of which formats browsers should support for images, for example, but the market has kind of worked that out. The market hasn't yet worked out which codec is going to win for audio, and video in HTML5. So the spec has a special way of making sure that everybody gets video. So instead of a source attribute on the video element, excuse me, we've got source elements, which are children of the video. And here I've got pointing at an MP4 for Safari and Internet Explorer. Here I'm pointing at WebM for Firefox 4, Opera and Chrome. And here I'm pointing at an OGG video for older versions of Firefox there. You should put the MP4 first. Generally, browsers will choose the first source file they know how to deal with. So it shouldn't actually make a difference, but there are bugs in some iPads whereby it will only look at the first source child. So if the first source child isn't the MP4, then the iPad or those versions of the iPad won't play any video. So just put the MP4 first. You'll notice here as well that I've got a type attribute. Now this isn't required. If you don't put it in, what will happen is that the browser will try to download a bit of each one of these until it meets one that it knows how to deal with. But video files are pretty heavy, and each one of these would be an extra HTTP request across a network, which are of course quite expensive, particularly on mobile devices. So if you put the type attribute and just tell it the MIME type, then the browser will know whether it should bother downloading that file or not, and you're saving yourself extraneous HTTP requests and downloading unnecessary bytes. So everybody wins there. And then in the middle you can still have your fallback content, which means that a clever man called Croc Cayman, who I believe is in the UK, he Frankensteined that horrible old cargo cult YouTube style code and HTML5 code to make something called video for everybody. So basically here he's got an HTML5 video element with the child sources, and then in the middle, which you'll remember is fallback content, he's got an object and he's passing the MP4 file to a Flash movie that he's got on the server, which serves as a video player. And then in the middle of that, for people who don't have HTML5 video or Flash, then you can have a link to downloading the video. So everybody gets video. People with old browsers who currently can only use Flash video will get Flash video, so they don't get a worse experience, but people with modern browsers will get that native video experience, and hooray for that. If you need any help with this, archive.org it has a great facility whereby you can upload the WebM version of your video and it will convert it to the other formats, and it will also host it. And then on your pages you could point your source children to the file hosted on archive.org, so you're not having to do the hosting yourself. But they'll only do that with Creative Commons licensed media. If you can't or don't want to license your stuff Creative Commons, there's a service called Vidly, vid.ly, and they have a free conversion and hosting service. You can look at that, maximum 1 gig source file, and what you do there is you upload the video to their website. They transcode it into lots of different formats, and then when a browser requests the URL, they will do various feature detection to work out which one of those video formats to send that particular browser. Or if you're just doing a few videos, you can download Miro video converter, and it's a drag and drop GUI skin, and then you just drag a video onto the Miro video converter, tell it what destination format you want, and it will do the conversion. But it only does one at a time, so you wouldn't really want to be doing that thousands of times. Personally, I expect to see some new CMSs coming to market, or maybe WordPress plugins, for example, whereby you upload a video into your CMS, and on the server in the CMS it will do the video conversions. That's not rocket science there. So there is help available to stop you having to do double encoding and hosting it all yourself. Now, I mentioned that one of the most powerful things about HTML5 Multimedia is the API. And this API is the same for audio and video, by the way. You have this, this is the spec, not terribly user-friendly, I have to admit. So here's how you control video with JavaScript. Basically, you do get element by tag name for the video, and then there's video play, pause, volume, whereby you can get and set the volume, and you can get and set the current time, which is how you can jump to places in the video, for example. And like every good API, there are events fired as well. So you get events fired on loaded data when it's playing, when it's paused, an event every 250 milliseconds called time update. It'll tell you when it's ended, etc. Each of the browsers fire those events in slightly different orders, and different events fire depending upon whether the video is in the browser cache or whether it's local, for example. So listen for the events and control your players by that. There are it's possible to get a race condition as well. I'm not going to go into detail with this, but if you look at html5demos.com excuse me, /video, this is a website that's made by my co-author Remy Sharp, and if you look at the code there, he explains the race condition he's encountering and how he gets around it. We consider it to be a little bit of a spec bug, but I don't think that it's solvable now. So have a look at that. Another thing that not a lot of people know is that you can attach media queries to videos. We all know and love CSS media queries, which drive what all the cool kids are calling responsive web design. And because HTML5 doesn't like to reinvent stuff, it likes to pave cowpaths, it pilfers and plagiarizes and steals excuse me, the media query syntax. So what's happening here is that I am giving a high-res video to devices with a wide screen. And I'm giving, therefore, a low-res video to devices with a small screen. There's no point in having a really great quality video if somebody to be watching it on a 1-inch square screen. This works in Safari and Opera. However, you do have to, again, double encode your video. You have to make a high-res and a low-res version. But this is doable now. Now, something else that everybody wants is full-screen video. For a long time, the spec said you couldn't go full screen in case people made movies that masqueraded as websites or something. WebKit has an enter full screen call like that. However, last month WebKit announced it's implementing the Gecko full screen API, and Opera likes this approach too. The good thing is with the Gecko full screen API is it can make anything full screen. So a canvas game could be full screen, and an iframe could be full screen, for example. It means that we have to think carefully about what you can do in full screen videos, which keys you can use, for example, and most importantly, how you let the user know that they're watching a video rather than seeing a web page. But these are all things that can be ironed out. So there is good hope for native full screen video with an interoperable API. So, video accessibility. I started my web standards career as an accessibility bore. And just because I'm now an HTML5 bore, it doesn't mean that I won't walk up to you at parties and subject you to accessibility tedium from time to time. I think the success of YouTube and similar sites has shown that video is a vital way of distributing content on the web now. And it is obviously vital that people who can't see or can't hear should still be able to perceive the content. So HTML5 works hard to make sure that there is accessible alternatives to video. However, none of this is implemented yet. So the stuff I'm going to show you right now is almost finished being specified, and I know that a couple of the browsers are working out how to implement it. As we progress through this presentation, the thing gets progressively more and more nebulous and further away from implementation. But first of all, maybe you know, maybe you don't, but inside your video container, your MP4 or WebM or OGG, whatever, there's a video track, there's an audio track, and there can be any number of subtitles tracks that the author has put in the container with the audio and the video. And what will happen pretty soon, I believe, is that when browsers open up the video container file to grab the pictures and the sound, they will also see if there are any subtitles available, and if there are, they will play them, which will be jolly. Also, you will be able to add your own subtitles, even if they aren't put into the media container. Now, at the moment, it's a bit of a chicken and egg situation. WebM doesn't yet have any mechanism of embedding subtitles, and that's because they're waiting for the HTML5 guys to specify the subtitling format, and then when the subtitling format is specified, then WebM will support it. So let's look at the format. What you will do if you want to add subtitles, because they're not actually in the video container, is you will use the track element. And the track element is a child of the video. You can have as many as you like. Here I've got English subtitles and I've got German subtitles, and I'm telling the browser which language these are in. And what you can expect of the browsers is that they will give you some kind of notification on the video itself that there are subtitles available, and it won't distinguish between ones you've added with a track element or ones that are actually part of the container file, and it will give you an opportunity to see those subtitles. So the format at the moment is something called WebVTT. This is a new format. It's loosely based on a street format called SRT. Now, there are at least 50 other specifications for timed tracks, but they're writing their own, and the reason is that as far as I can tell, they're trying to strike a balance between simplicity and power. Because if you have a super duper subtitling language, it will be so complex that real people aren't going to write it. And if nobody writes subtitles, then there's no point at all in specifying how to display them. So here's a nice simple version. The spec's actually changed since I put this presentation together, so now you don't even need the word file here, just WebVTT. It's a simple text file, UTF-8 encoded. This number here is optional, and these are hours, minutes, seconds and milliseconds from the beginning of the video. And at this point from the beginning of the video until this point from the beginning of the video, display this text. And that's pretty much as simple as it can be. We find that real people, not web developers, real people out in the real world are using a format very much like this to subtitle their videos on YouTube, which is why the format is based upon that, and it's nice and simple. You can do more stuff. So WebVTT supports positioning of text. You can say show this 10% from the top or 10% from the bottom. You can surround various words with B and I for emphasis. You can colour individual speakers so that if two people are talking at the same time, you could have everything Paul Irish says being purple and everything John Folio says being blue, for example. And that would be useful. It supports vertical text for languages like Chinese because, of course, the entire world doesn't speak English. And equally well, it supports right-to-left languages like Arabic. It also supports Ruby annotations for Chinese, Japanese, and Korean languages. And these are ways of telling readers how to pronounce some potentially unfamiliar or ambiguous characters in those Eastern languages. These are built in because internationalization and accessibility are absolutely integral to the modern web. Now, currently, no browser yet supports WebVTT, and the spec isn't completely finalised yet. However, we can polyfill this. I don't know whether you guys in the USA have this product called Polyfiller. But Polyfiller basically is a way, it's a product and you put it over cracks in the wall, etc. It hardens and you sand it down, and you're left with a smooth surface upon which to paint. So polyfilling is a term invented by my co-author Remy Sharp. And basically it's a methodology whereby you code to the specification, you code to the standard, and you have a small polyfilling script, and the polyfilling script does feature detection, which is easy and built into HTML5. And so this script I'm going to show you, which is written by a Frenchman who goes by the name of Delphiki, and it's called Player, P-L-A-Y-R, with the last vowel oh so fashionably left out. What this is going to do is fake track support in JavaScript. The first thing it does is check whether the browsers natively support track. If they do, then the script just finishes and hands over support to the native browser support. If it doesn't natively support it, then the polyfilling script takes over and does the job, and it will XHR in the VTT files and look at the timestamps, and using the Media Elements API, it will synchronize the text with the video. And it looks a little bit like this. So Player has made this nice...
Hi, it's really great to be here, and Her Majesty the Queen has commanded me to send you her royal felicitations. Have a marvellous day.
So Player's made this nice video skin for me. However, it's noticed, because of those track elements, that there are two subtitle files, and it's getting the information about the language from the source lang attribute. So if I switch it to English...
Hi, it's really great to be here, and Her Majesty the Queen has commanded me to send you her royal felicitations.
It's worth pointing out that this is just text, and just text is fabulous and groovy because, of course, just text can be indexed by search engines, and just text can be easily styled with CSS. The user can bump up the browser defaults to make that bigger and do with it as they will.
Have a marvellous day.
As you could probably tell, I was on Bondi Beach there before Christmas. I went to do a talk in Australia, and obviously, because I'm courteous to my hosts, I subtitled this into Australian as well.
Hi, it's really great to be here, and Her Majesty the Queen has commanded me to send you her royal felicitations. Have a marvellous day.
So you can see this is faking browser support, but I expect it to look, excuse me, very, very similar in browsers. This is a player, like I said, Playr. The source for this is on GitHub, and you are free to grab it. Thank you to Mr. Delphicke. I also want to point out a really cool script here called Media Elements.js. That's mediaelementsjs.com, and this does a similar thing. In fact, it uses some of Player's code, but not only does it fake track support, but it actually contains within it custom Flash and Silverlight players that mimic the HTML5 API for older browsers. So this absolutely rocks and is thoroughly recommended. This one uses JavaScript. This one uses the jQuery library, so it's a little bit bigger, but it's doing loads more. So it really depends upon what you need to do. Okay, so not everybody needs excuse me, text equivalents. For example, here's a web page from the Fire Brigade near me, and they have a video of a lady who is signing a video in British Sign Language. And what you want here, excuse me, is if I change the position of the video here, I want the video here to simultaneously change so that her signing is always synchronized with the video. Like many things accessibility related, there are many uses for those things outside the arena of disability. So here, for example, is a sporting event with multiple camera angles, and what you would want here is if you changed the position of the video here, you would equally want these ones to change as well. And the spec has something called synchronizing media elements going on with the concept of a media controller, and whereby you group elements together and they're all slaved to each other. This is much less mature than the web VTT and the track elements, but to me, as an accessibility bore, it's really encouraging that we're talking about this stuff now and working on a standardized, interoperable way to make multimedia accessible out of the box in browsers. Coming soon, I'm sure, actually, because people are demanding it. So let's have a look at how mature all this is. Now, there's looping latency at the moment in the browsers. That it's getting better, but my colleague Patrick Lauker has done some experiments on how you can do seamless looping, which is difficult at the moment. There are a lot of video issues on the iPad, some of which are solvable, and some of them are seemingly not solved yet. And for things like the iPhone, Remy Sharp, my co-author, has a really good blog post on audio sprites, because you can't play two sounds simultaneously. So it's not fully mature yet. On your media players on your operating system, you got a lot more features because they've had a decade's worth of experience, and this is all very new in browsers. But it's fixes are coming through thick and fast. People want this stuff, and the browser manufacturers, we know this, and so we're fixing stuff. Now, one of the things that HTML5 was invented for was to compete with things like Flash and Silverlight. I personally think that competition's good, and if one kills the other one, then that's bad, because that negates competition. But a lot of people are still in the false dichotomy, if you like, the black and white mindset of it must be HTML5 or Flash. One's good and one's evil, and it depends upon your viewpoint which is which. A lot of the people who are Flash is great people, they come up to me and say, HTML5 doesn't have DRM, digital rights management. So let's talk about DRM. Now this is a slide that was drawn for me by this 6-year-old lad here, whose name is Jack Henderson. About the slide, Jack's little brother Noah goes in and out of hospital quite a lot, and so 6-year-old Jack decided to raise money for the hospital that looks after his little brother. And he had the idea that he would draw anything that people asked in return for a donation. And he was trying to raise £100 sterling. He's raised £20,000 sterling, and I wrote to him and asked him to draw me a picture of the words DRM because I needed a slide. And luckily, Jack's dad, Ed, is a web developer, so he fast-tracked my request. If a 6-year-old boy knows that DRM is scary and horrible, I think that tells us all not to do it. However, I should add at this point, this is my personal perspective and does not reflect the opinion of Opera. So when people say to me, well, you know, HTML5 doesn't have DRM, I say, yeah, and I don't have syphilis, and I find nothing to regret in either of those two statements. Frankly, I think DRM doesn't really work. I think this is a great visual image of DRM, but people want it, and I understand that organisations need to be able to show that they're doing their best to protect people's copyright. At South by Southwest this year, I asked Paul Cotton, who's one of the co-chairs of the working group, and I suggested that DRM wasn't actually part of the language anyway, that it isn't HTML's job to protect copyright, and I postulated that maybe DRM was actually a format problem. If somebody wanted to supplement WebM and MP4 with, you know, a .drm web format that only browsers with the right keys could play, they'd be absolutely welcome to, but it's not part of the language's job. And Paul, to be fair, agreed with that. So we'll see how it goes. But if you do need it, it's worth noticing that Henry Sivanen, who is a guy who works for Mozilla, showed how you could actually do DRM for video already in HTML5 without any spec changes. So if DRM is your thing, that's the link to look at, kids. Okay, let's have a look at the future now, because tempus fugit, it's time's moving on. So let's look at the future. The HTML5 spec had something called the device element, which now has changed its name and changed from an element to an API, and it's called Get User Media. Something new on the scene is WebRTC. This is Web Real-Time Communications. So this is basically video conferencing in the browser with JavaScript APIs. It's been the code has been open sourced by Google. It's a project supported by Google, Mozilla, and Opera, and it's basically allowing your devices, your computer or your phone, with your permission, much like the way you have to give permission to the geolocation API. With your permission, a website can access the camera and the microphone on your device from JavaScript, and there is an HTML5 spec for peer-to-peer communication. Not yet ready for prime time, but getting there. And this will allow basically peer-to-peer communication between devices with audio and video. It's not in any browsers yet. However, in Opera we do have this. As you can see here, I've got an auto-playing video with nothing inside it. Then in my script, I'm doing feature detection to see if I have Get User Media enabled. And if I have, basically I'm connecting the stream from my camera or microphone to the source of that video element. And that is allowing me to connect my camera to a video element on the screen. So if you download a labs build of Opera Mobile for Android, you can see this this fabulous demo, and what this does is it's a website. It's not an app. It's not a native app. It's just a JavaScript website. And what it's doing is it's accessing the camera and getting a picture of this guy. Then it's doing facial recognition and drawing a Super Mario mustache where it should go. And I think there is very few finer demonstrations of technology. So this isn't doing the peer-to-peer video conferencing yet, but you can see the ramifications of this for augmented reality. For example, if you go to this URL here and download the build, in the speed dial on that build, there are links to demos. There's a demo which uses get user media to get the camera into a video on the screen, copied into Canvas, and then it uses the geolocation and the orientation API to work out which direction you're walking in and where you are. And it would be then, of course, the extension to that is some kind of augmented reality whereby it tells you the nearest subway station or turn-by-turn instructions to the nearest bank ATM if you go to your bank's website and allow it to look at your camera. These things are all possible if you want to code them, and you can download that labs build from Opera there. So we've looked at what's possible now. We've looked at coming soon with subtitling on the track element, stuff that's a little bit further away with synchronized media and getting and doing real-time communications. So let's have a little case study. Let's have a look at what the power of HTML5 can give us now. This is, by the way, a painting my daughter did for me on Father's Day. This is me on a unicorn with a Turkish dancing girl, killing Nazis with lasers that are powered with HTML5. And all this can be yours if you come to the HTML5 Lite. Okay, so there is a marvelous old game from the B3TA guys, who are a rude website in the UK. And this is almost certainly 9 or 10 years old now. Rathergood.com/Buffy, and this is Buffy's swearing keyboard. So let's go there. So this is Buffy's swearing keyboard. Now if I hit A, for example, hopefully you could hear that. So here's A, here's B. I'm not going to hit C for obvious reasons, but here's D. And you get the message. But of course, this unique cultural artifact is all Flash, which means, of course, that all you cool iPad and iPhone users can't use it. And it seems a shame for this integral part of internet history to be locked in a proprietary format. So I decided that what would be good is to remake this in HTML5. So my first thought, when I showed this to my daughter, who of course laughed and enjoyed pressing all the rude keys, the first thing she said was, well, who's Buffy? And of course, ladies and gentlemen, it's a tragic fact, but young people of today don't know who Buffy is. So then I got to thinking, okay, so if I'm modernising the code of this, I ought to modernise the celebrity. So I started thinking, well, Lady Gaga's swearing keyboard, yeah, maybe. And then of course I realised, who is it who has excellent geek kudos as well as being down with the kids? And the answer was obvious. Ian Hickson, the editor of the HTML5 Spec. So instead of Buffy's swearing keyboard, I'm going to use Hicksy. And of course, Hicksy, as he attended a British university, is a man of refinement and good manners and would never swear. So it's going to be Hicksy's HTML5 keyboard that we're making based upon Buffy's swearing keyboard. So the first thing I've got is basically the keyboard. Excuse me, and this is just a collection of HTML buttons, and they're arranged in divs, one for each row. They're divs rather than any other semantic element, because of course the grouping is entirely arbitrary. It's visual. There's no there's no logic to the grouping. So I've given them divs, and they're just buttons. Then the next thing I've got is a loop of Hicks's head talking. It's just a 2-second loop that I've done. Here it is. You can slightly see the join there. It's a 2-second loop because I don't want to download a great big video. So what I'm going to do is basically loop that video while he's talking, and when the words he's saying finishes, I'm going to stop the video programmatically using script. So what I'm going to do here is we're going to race through this code, but basically I'm looping through all the buttons, and I'm adding a new OGG file to the end of my web page. Where I'm making this cross-browser, I'd also add an MP3 file as well. And basically I've got a.ogg and a.mp3 for the thing he says when I press the A, and then b.ogg, c.ogg, d.ogg, etc. Right, now here's the important thing. What I'm doing is I'm listening out for a button to be pressed. When the button's pressed, I start the audio, but all the audio are of different lengths, so I listen out for an ended event, and if the ended event has come from the audio, then I pause the video. So that synchronizes the video with the audio. To say that again, I press the button, it triggers the audio. The end of the, and it also triggers the video, and the end of the audio triggers the video to pause. Okay, so what I want to do is get the words on the screen as well. So I'm using the data attribute. Any element in HTML5 can have a data attribute attached. It can be data hyphen anything you like. It could be data hyphen text, data hyphen shield strength, data hyphen spaceship size, and it passes information to scripts. And what I'm doing here is I'm passing the words he's saying off to the script, and that will be overlaid on the page. So I'm grabbing the value of the data attribute there, and then I'm just overlaying it on a div which is absolutely positioned over my keyboard, and I'm using a CSS3 font face. So let's have a look at how that works. Okay, so here it is. Now when I hit a key, you'll see Hicksy start, and when the words he's saying finish, he will finish. So let's go through it one by one.
Article, BDI, canvas, details, embed, figure in fig caption. Geolocation isn't really part of HTML5. Header, item prop, JavaScript is lovely. Keygen, local storage, menu and meter, nav, output, post message, progress, pattern, placeholder, queue element, Ruby, section, time, UTF-8, video, web workers. Yeah, what's your use case? Z-index, because CSS is part of HTML5, bitches.
Ah, I just realised I forgot X.
XHTML2, my arse.
And there, ladies and gentlemen, is Hicksy's swearing keyboard, made through the magic of HTML5 Multimedia, HTML elements, CSS3, and the JavaScript API. And thanks to these guys for all their help. Thanks to the All Rights Reserved corner, Takara Tomy for the Giga Pudding video, which belongs to them. Buy the pudding. Jack Henderson for permission to use his scary DRM picture. Buy his book, Thanks to my daughter for the HTML5 Nazi killing Bruce on a unicorn picture, and by her dad's book, which is here. Introducing HTML5 second edition, coming out in September. And with that, ladies and gentlemen, any questions?
Thanks for your presentation, and thanks for getting up at the wee hours of the morning to
I just never go to bed.
Sorry to hear that. So, questions for Bruce. So the question is, Bruce, he's asking, Microsoft has announced that they're phasing out Silverlight. Do you know anything about what they might be doing next?
They've just announced they're phasing out Silverlight, really. I haven't seen that announcement. Obviously, I can't speak for our friends in Microsoft because I work for Opera. But I would imagine, looking at what they've announced for Windows 8, that all apps will be made in HTML5. That's the way they're going, and that's the right way. Let's hope that applications on WinPhone 7 will be similarly open and not require Silverlight too. But I'm afraid I can't answer in any more detail than that, simply because they haven't yet told me all their plans for the future.
Okay, thank you. We have another question. Just hold on 1 second.
Go for it.
Okay, Bruce, the question is there any way to do post-processing on video that's playing in a web page just using the video tag?
So you mean muck about with the video in real time? Is that what the gentleman's asking?
Yes.
Yeah, no problem at all. So the the video, the demo that I alluded to, where we draw a Mario mustache on you, what you see on the screen isn't actually the video element at all. The video element is hidden away from the screen, and what you're seeing on the screen is a canvas, and then so the video is being copied pixel by pixel into canvas in real time. And then we're doing analysis of the pixel data in Canvas to find a face, which is pretty trivial. It's looking for certain areas of uniform color with two dots in it, which would be eyes. And then on the canvas, it's drawing the red square around where it thinks the face is and adding the mustache. So that's post-processing of the video, but that's done copying the video pixel by pixel, frame by frame in real time into a canvas and manipulating that data. There's a really great demo by Paul Roger of Mozilla, in which a colleague of his is standing in front of a green screen, and they're copying that data into canvas. They're checking for the amount of green on a certain pixel. If it's above a certain threshold, they're making that pixel transparent. Then they're putting a background image on the canvas with CSS, and it looks like the guy is standing in front of that background image. And this is all done real time in the browser, copying the video data into Canvas and manipulating it that way. So yeah, possible, and there's demos around that are a couple of years old that can show you how to do it. Did that answer the question?
Yes, thank you. Sorry, so we have a question online. We were wondering when you estimate RTC will be available in major browsers, or the timeline for that?
As it says on the website, we hope it will be available for Chrome, Opera, and Firefox soon. It really is brand new stuff. When we were implementing that Mario mustache demo in Opera, for example, we collected lots of feedback on the streaming protocol, which we hope will be factored into the spec. So it's like a lot of the really bleeding edge HTML5 stuff. The spec is kind of half there. As we implement it, we collectively, as we implement it, we'll get feedback on the spec, and the spec will be tarted up. And there's a feedback loop going on there. But we hope it will be soon. That is months rather than years. But I didn't say that.
Excellent, thank you. We have another question in the room. Just hold on 1 second. Have you heard of a text-to-speech API that, sorry, could you repeat that? For accessibility?
there are add-on programs that will do that. For me, personally, I think text-to-speech is a job for, it's an add-on to the browser rather than API, personally. There's many such things. In Opera, we have a built-in voice synthesizer. There are some great screen readers that you can get. I'd advise you try NVDA, which is, I think I said in the presentation, two blind guys in Australia make it. That's nvda-project.org. But no, I haven't heard of, of an API.
Okay, thank you. So he's asking whether or not you can prioritize video streaming and a web page that has other streaming elements in it.
If that's something you can do on a server now, then yes. I'm afraid I'm just not enough of a server monkey to know whether it's possible on the server to say this thing gets higher priority, but not client side, no. And there's a whole swathe of things, like adaptive bit rates and things like that aren't simply possible in HTML5 yet. People know about them, people are working on them. These deficiencies are basically because this stuff is very new rather than nobody cares about it. And one of the things with building new languages like this is that you start off with a version 1, get the foundation there, and then riff off of that rather than try and get everything perfect before you release. These things, I'm sure, we'll be seeing those pop up in the next year or two, but no, not easily yet, as far as I know.
Someone's asking whether SVG will ever become a first-class citizen in the HTML5 arena.
I could be annoying and puritanical and say no because SVG is nothing to do with HTML5, but I'm not going to be annoying and puritanical. I'm going to say yes, it already is a first-class citizen of the HTML5 arena, particularly when Internet Explorer 9 announced that it had support. In fact, later on, when I can dig out the link, I'll post a link which is manipulating HTML5 video in real time using SVG. So just with an SVG filter, you can do edge detection, you can make things monochrome, you can invert the colors. And if you look at Swiffy, which is an experimental Google web app, that will take a Flash SWIFT that you upload and it will vomit it back out in what it calls HTML5. What it actually is SVG. Unfortunately, it's SVG that seems to only work in WebKit browsers, which is a shame. But nevertheless, it's SVG. So, yeah, SVG is here, and finally, several years after it appeared on the scene, is ready for prime time. Did that answer the question?
Excellent. Yes, I think it did. Thank you. Okay, we have one question online. Just let me grab that. Okay. G'day, he says. We have a graphic intensive app in FlexFlash, which is used by schools with old browsers. We're setting up a new team to create the app in JavaScript HTML5 using Canvas and drag and drop. What aspects of HTML5 need to mature to ensure it's robust?
I have a feeling that it's not the aspects of HTML5 particularly that need to mature, but I'd look very carefully at how old and how capable your target browsers are, because doing the stuff in JavaScript can be CPU intensive, and if you're trying to polyfill loads of stuff so it's all going to work in IE6, you're going to have a hard job on your hands. Is the honest answer.
Okay, thank you.
Bless you, Vanessa. Thank you ever so much for attending and listening, and thank you to Vanessa and Max for several evenings running up to this, working out how on earth we were going to technically stream it. I'm enormously grateful to them both.
The feeling's mutual. We thank you very much, Bruce. Thank you.
Take it easy, San Francisco. Bye.